in Chapter 8, Collections. Before, we've already seen how to create lists. You can just write collection.list of num and you get your list of numbers. Or you can just write num.list to use the list of numbers provided by Adam's towel. The easiest way to initialize a list is just to put the elements between the square brackets. If we just create a list like this, it will be a mutable list. That is, a list that we can use to add and remove elements. If we want an immutable list, we have to specify the type. And so we can either write the class name without specifying a modifier so that we get to the im default, or we can just write im and let the language infer the class name. This doesn't just work directly after you have created your list. If your list is returned by a method call, you can specify the type in this manner and still turn your mutable list into immutable. That is, the result of every method call that can input 0 mutable objects can be promoted to immutable, just specifying the types after it. So, if you have a method that gives you a list of mutable numbers, you can assign it to an im local binder and get this promoted to im. On the other side, if you just assign it to the binding without specifying the type system will infer the type as being the same as the return type of get mutable nums. In the case of our example, mutable. Adam's towel is giving you a lot of useful operations for your immutable lists. So we can use plus, 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 minus, and minus, minus to combine lists. So for example, nums of a, b, c plus d is just going to be nums of a, b, c, d. That is, we put d from outside and we jammed it in. We jammed it in? Did we mutate the list? No. Those are all immutable operations. So every time we do something, what we are doing is that we are creating a new list that looks like the old one, but with some little difference. So here we create a new list that looks like the old one, but with the added d in the end. We can also add an element at the front and an element at the bottom. So here we have k plus abc plus d, and it's going to give us k, abc, and d. If you have two sequences, you can concatenate them with plus plus. So plus to add a single element, plus plus to add two collections together. We can remove an element with minus. So a, b, b, c minus b, have you noticed that there are two b's? Minus b is going to remove both b's, and so we are going to get a collection with just a and c in output. We can also use minus minus to remove all the elements from one collection. And in this way, if we have A, B, B, C, and we remove B and C, we just get the collection with a single letter A. Note how we are using assertions, that is, the x square bracket syntax, to show the expected behavior of our operations. That is, every time we show operations in this assertion way, those are assertions that will pass. In addition to plus, 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 minus, 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 we also have a lot of named methods. For example, with to val e, we can set the element e in position 2. So if we have a, b, c, d, then we will have a, b, e, d. So a is in position 0, b is in position 1, c is in position 2, and d is in position 3. We are replacing the one in position 2, so we are replacing c. For convenience, we can also call with left and with right to just update the rightmost and the leftmost element from our list. Again, we are not mutating any object here. We are just creating a new list that looks like the old one, but with a little bit of a difference. If we want to add more elements, we can use with also. So with also in position 2 will add the new element after the element in the index 2. So with also 2e, we'll add the element e in position 2, and all the other ones are going to be shift one place. So if we start with a in position 0, b, c, d, and we add e in 2, we end up with a, b, e in position 2, and then c that was in 2 now goes in 3, and d that was in 3 now goes in 4. Again, we can use with also left and with also right for convenience to add in the leftmost position or in the rightmost position. We can remove elements with without. So without 2, we remove the element in position 2. So we can go from A, B, C, D to A, B, D. And again, we have without left and without right. We can also have without all, that takes an element and removes all the occurrence of that element. And this is just the behavior of minus minus, but as a named method. So if you prefer the operator, you can use minus minus. If you prefer a named method, you can use without all. Notice how we are using val as the name of the parameter of without all. List is doing this consistently. Every time we are talking about an element, we are using val. If the element is the leftmost, we are just using left. If the element is the rightmost, we are just using right. If it is an element, we are just using val. We can also remove the leftmost or the rightmost element from a collection. Without all removes all the occurrence of an element. If we want to remove just one occurrence of the element, then we have to specify if we want to remove the one more on the left or the one more on the right. If you want to just get elements, you can use left to get the leftmost, right to get the rightmost, val and an index to get the element in that position. You can use size to get the size of the collection, that is going to be equal to the maximum valid index plus 1. And you can check if your collection is empty. At this point, you may have noticed that I really like immutable lists. I think they are so much easier to reason and it's so much harder to get a mistake while working with them. However, mutable lists can be significantly more efficient. And so we have a lot of operations also to mutate lists in place. So to mutate a list, we need a mute or a length list, and we can call set to actually update the value in position 2 to E. So if our list starts with A, B, C, D, then this list will now be mutated to be A, B, E, D. And for convenience, we can update the leftmost element or the rightmost element. We can also inject a new element into the list in a certain point and make all the elements on the right move forward one step. So we can have add to val equal E, and we will get A, B, E, C, D. We can also add to the left or to the right. We can remove an element in a certain position, or we can remove the rightmost or the leftmost one. As for without all, we have remove all. That removes all the elements that look like B from our list. That is, both removes all and without all uses some kind of equality criterion to remove our elements from the list. Again, symmetrically to without left and without right, we can have remove left and without right that remove the leftmost occurrence of an element or the rightmost occurrence of an element. Okay, this is all for today. Next time we are going to see how to iterate on lists and how to make views on lists.